Now, question number 4. In the diagram below, the graphs of f of x, a cubic function, and g of x, which is a hyperbola, are given. E is a point of intersection of the graph of f and g, right, at that point. Now, f is the point of inflection of f. So there we have a stationary point. The point of inflection, that is where we change concavity. Okay, and then we are told that the graph of f cuts the x-axis at x is equals to a half and touches it at x is equals to a -3 and cuts the y-axis at a +9. Okay, now the first question number number 1. Show that a is equals to a -2, b a -11, c -12, then d +9. So in other words, we are required to find what the equation of this cubic function is. And yeah, we're given plenty of information to find the equation, right? We've got our roots, our intercepts, our y-intercept, that is 0 and 9. And then since here we also have a turning point, so that means we've got two identical roots, the x-intercept and also, yeah, so that means here we've got something like x plus 3 square, and then here it's just x minus half. So I'll rewrite my cubic function and say y is equals to a, so that I know the shape of my function, and I'm expecting a to be a negative number, right? Okay, yeah, even though we're given, oh, not given, rather required to prove. So we'll have x plus 3 square and then x minus a half. Now I will expand that, so I'll have a, so firstly this one will have x squared plus 6x then plus a 9, all of that multiplied by x minus a half. So let me get rid of my brackets again. So we'll have x cubed and then we'll have a minus half x squared, and then I'll have plus 6x squared and then minus 3x, then 9 times x, that's a plus 9x, and then I'll have a negative 9 halves. Now let's simplify like terms. We've got x squared and x squared, so minus half plus 6, that's just the same as minus 1 plus 12, which is a positive 11 divided by 2x squared. I still have my x cubed there. Okay, and then another like terms, it's 3x and 9, so that will be a positive 6x then minus 9 halves. Now I've got two unknowns, I have a and x, so I can use my additional point at that point, which is our y-intercept. So our value of y there, we have the value 9, and then our x value is 0, so everything will be 0 0 0, and I'll remain with minus 9 divided by 2. So I'll just quickly solve this. We'll have a is equals to negative 18 divided by 9, which is equals to a negative 2. And then I will substitute this a is equals to a negative 2 into that to find my full equation. So now we'll have f of x, I'll multiply everything by negative 2a, so I'll have negative, not negative 2a, negative 2, so I'll have negative x cubed, the 2's would cancel, so I'll have a negative 11x squared, and then 6 times negative 2, that's going to be a negative 12x, and then the 2's will cancel here, and then I'll have a positive 9, since it's a negative times a negative. So this is our function of f of x, And indeed our a is less than 0, that's that, and then our b is 11, our c is a minus 12, and then that's our d, the y-intercept. And then number 2, determine the x-coordinate of f. Okay, at f we are told that that is a point of inflection, stationary point, right? So whenever we want to find the point of inflection, we take the second derivative of our cubic function and then equate that to 0. So what I will do, I'll take the first derivative, f of prime, of that function. That's going to be a negative 6x squared minus 22x minus 12. And then the second derivative, that's going to be minus 12x minus 22. And then I'll equate this to 0. So 0 is equals to minus 12x minus 22. So I'll have my x values equals to negative 22 divided by 12. And the lowest common multiple here, it's the value 2. So I'll have negative 11 divided by 6. So that means our x value at that stationary point f, okay, it's equals to negative 11 divided by 6. Question number B. If the gradient at point E of the graph of f of x is 8, determine the coordinates of E. So now we are required to find the coordinates at point E, where these two functions, they are equal. Okay, and in this instance, since we're given the gradient of this function at that point, we will not use like how we normally try to find where two functions intersect, where we equate their equations and solve for x. So we'll just take the first derivative of the function f and then equate it to the value 8, because we are told that at that point the gradient is 8. So meaning if ever we were to draw a tangent line there at that point, and this tangent line, let us say it has a gradient of 8, let us solve for x there. So the first derivative there, we have it already, so I'll just go ahead and equate that to a positive 8, right? So I'll say 8 is equals to negative 6x squared minus 22x minus 12. And then I'll transpose 8 to the other side. Minus 22x minus 12 minus 8, that's a minus 20. And then just to simplify this, I'll divide everything by a negative 2, so that I make my, or rather I make this trinomial easier to factorize. So dividing everything by negative 2, I'll have 3x squared minus, or rather it's going to be positive 11x, then positive 10. Now I can factorize this and say 3x, my factors, and everything will be positive. And then factors of 10 that give me 11x, I don't have. But I can have 6x plus 5x. So I can say 5 there, and then 2. So now that means I have 3x is equals to a negative 5. So our x is equals to a negative 5 divided by 3, or x is equals to a negative 2. So which one is the correct x value? And both of them are negative, right? So we are in the right part of our axis. But which one is correct? So I think part of the reason why we were required to find what our x value here in this stationary point, it's so that we can assist ourselves to know what the x coordinates here at E is. Let's just get the rough approximation of this. 11 divided by 6. 11 divided by 6, that's a negative 1.88. So if ever at that point we've got a negative 1.83 recurring, then at E we've got to have a lesser value than that. And if ever I look at my solutions for E, negative 5 divided by 3, what is that? 5 divided by 3, that's approximately negative 1.67, right? Is it less than that? 11 divided by 3, is it? 11 divided by 3, yeah. No man, 11 divided by 6. Nah, see, this value is greater than, which does not make sense. So this is not a valid solution because this is greater than our x value there. We can't have the x value here greater than the x value there. It does not make sense. So that means our correct solution, it should be x is equals to a negative 2. And then now let us find our y value. So we'll just say negative 2. These are coordinates of E, right? Negative 2, and then we substitute negative 2 into our original function. And then I will just pause the video and find what my y value is. Okay, and then my y value there, it's a positive 5. So I'm getting a positive 5. So in E, we've got negative 2 and 5. That's at E. Now, question number C. If the graph of G has a vertical asymptote at the minimum stationary point of F, determine the equation of G in the form y is equals to 2 divided by x plus p plus q. So now we are required to find the equation of that hyperbola. And we are told that this hyperbola has a vertical asymptote at the stationary point, or rather, what is it? Minimum stationary point. And we have a local minimum here for this function f, so meaning somewhere there. So obviously that's at that point. So that means we have a vertical asymptote. Let's draw that asymptote. We have it like that. Okay. And that's for the hyperbola, right? Okay, let me just create some space here. Let me move everything here. Let's move that. Let's move to the other side. I can delete that, doesn't matter. Okay. So in other ways, we can rewrite this equation and say y is equals to 2 divided by x plus 3, because that is where this function of g is not defined, plus q. Now our only unknown is that value q, of which it's also a horizontal asymptote. So what other point can we use to find this equation? We have that point E, our previous solution. Point E lies on both F and G. So I will use E. My y value is 5. Then that's going to be 2 divided by minus 2 plus 3 plus q. So to simplify this, I will have a 2 divided by 1. So I can just say 5 minus 2. And q is equals to a positive 3. So that means our function of g of x is defined by 2 divided by x plus 3 plus 3. That means our horizontal asymptote, it's the line y is equals to 3. And where can we draw that line? So meaning it's supposed to be between these two parts of our function. It's supposed to be somewhere there. So that's the line y is equals to 3. And then question number E. Okay. Determine the values of x. Oh no, skip question number D. Determine the equation of the axis of symmetry of the graph of G that has a positive gradient. So we need to find the axis of symmetry for this. And let me just draw the one that has a positive, a positive gradient. So we are required to find the equation of this axis of what did I do now? Okay, good. I need to find the equation of these axes of symmetry. Okay, at least let's give that a purple color. The equation of that line. Okay, so that line crosses at the cross section of our asymptotes, which is a -3 and a +3. And remember, for our mother graph, y is equals to 8 divided by x. The axis of symmetry with the positive gradient is just y is equals to x. So that means this function is shifted 3 units to the left. So I will say y is equals to, shifting that 3 units to the left, I will say x plus 3. And then it's shifted 2 units upwards, not 2, 3 units. Those units, it's shifted 3 units upwards. So that means I will say plus 3. And this will be the equation of my symmetry. So that's going to be x plus 6. So that's the axis of symmetry with a positive gradient. That's for question number D. And then question number E. Determine the values of x for which f of x is greater than and equals to g of x in the interval where x is an element from -infinity up until 0 and 0 is included. Okay, meaning on the left side of our Cartesian plane, right? We need to find where our function of f is greater than g. So let me just let me erase some things. Erase these coordinates. Even that one, let's delete that. Now let's look at our function of f. Our function of f, from this portion coming from -infinity, it's above g. It's above g. So from -infinity up until this point, it's always above g. So we can describe this portion as from -infinity up until at -3. However, -3, we don't have our function of g defined, so hence I'm doing a round bracket. And then from my asymptote, which is the value -3, right, up until e, the point of intersection, my function of g is above f, so that is not a valid solution. However, from that intersection point, which is my value of x is equals to -2, right? Let's make that with a square bracket because it is included. From -2 up until whenever my x value is 0, because that's where we end, my function of f is above the function of g. So up until 0 with square brackets. So that's my solution. That's for E. I can say from -infinity up until -3 with the round brackets, union of square brackets, -2 up until 0. Yeah, it's when x is an element of that. And then question number F. Determine the values of k if the graph of f is shifted so that the new graph h at x minus k is equals to my f of x, right? This is just f of x. Does not intersect the graph of g for x values that are greater than or equals to 0. Okay, so now we are given a new function. There's a new function that is defined by h of x minus k is equals to f of x. However, this function h at x, we are told that it should not intersect that function. It should not intersect g of x, right? Not intersect g of x whenever our x values are greater than or equals to 0. So we are asked what values of k make this function to satisfy that statement. So I can rewrite this and say h at x is equals to f of x plus k. So what I will do here, just to represent this geometrically, or rather show how I arrive at my solution. Let me do this. Okay, let's say let me use a different pen. Let me use a green pen, and let me use a bold. So let me just do a duplicate of my function of f. So let's pretend this function is an identical duplicate of the function of f. However, this new function is h at x, and I don't want it intersecting my g from this part of my axis, from 0 going to the right. So how I can achieve that? It's, let's say I will move this function and I will move it vertically. So let's say I move my function vertically downwards, right? And the moment it is there, I'm only intersecting my function of g on top of that y-axis. So what's the intercept of the g? I think we need to find that. Do we have it? No, we don't. So whenever I have this new function of h intersecting there, I no longer have it intersecting whenever my x is greater than 0. However, I'm also not supposed to intersect it whenever x is equals to 0. So the best way is to make this function h at x, right, to intersect exactly where my function g of x intersect that y-axis. So let us make an equation that satisfies this graphical presentation here. So first we need to know where our g of x is intersecting that y-intercept. So let me just, this is for the last question, which is number F. It's F. Go back to my black pen. So what's the equation of the hyperbola? Okay, there, it's easy. So for hyperbola is equals to 2 divided by x plus 3 plus 3. And to find the y-intercept, let x is equals to 0. So I'll have y is equals to 2 divided by 3, then plus 3. So this is just the same as 2 plus 9, yeah, which is 11 divided by 3. So that means our g is intercepting at 11 divided by 3. So that means I want to make my h at x to also intercept at that point. So using that equation, I can say, okay, the equation that we have there. So I can say minus 2x cubed minus 11x squared minus 12x plus 9. So I want to make this function to intercept at 11 divided by 3. And we know from a cubic function, our y-intercept, it's that value d. It's that value. So for now, all of these does not matter. So that means I can say, using this, I can say 9 plus k is equals to, what do I want? I want that to be 11 divided by 3, right? And then I'll solve for k. So 11 minus 11 divided by 3. What am I doing? 11 divided by 3 minus 9. I'm getting a negative 16 divided by 3. So in order to make h at x, okay, let's just say f of x, not f of x. Let's just say my y-intercept of this function. Yeah, it's at, no, for it to be at that value. So in other words, I'm rewriting this. So I'll have, let me write everything in full. This is just for completion, right? So cube, then minus 11x squared minus 12x plus 9, then plus, I'm substituting my value of k here. So that's minus 11, no, that's minus 16 divided by 3. So what is that? What's my 9 minus 16 divided by 3? Okay, yeah, it should be. It's all of that. Yeah. Let me just say this. Let's call that capital letter A. That's all of this, because for now, this is not our focus. All of that is just A. Plus 11 divided by 3. That's my y-intercept of this new function h at x. Okay, no? And to make this function h at x to intercept at that point, I had to add a negative 16 divided by 3. So if ever I intercept at that point, so I'm no longer intercepting my function of g when x is greater than 0. So the first part, we've got that correct. The only missing part now is that even if our x is equals to 0, we are still not supposed to intersect the function g. So how do we make our new function h at x to not intersect g even if our x value is 0? So that means we've got to add, our value of k has to be less than that. So let me just get an approximation of negative 16 divided by 3. Negative 16 divided by 3 is approximately, this is approximately to negative 5.3, 0.3 recurring. So what other value is less than that? Let's just take negative 5.34, which we know that is less than that. So if ever we add a value that is lesser than that, that means our y-intercept will no longer be that value. Instead, it's going to lie below that value. So meaning our function will further move downwards. For now, we are intercepting at 11 divided by 3, right? But if ever we add our k is less than negative 16 divided by 3, our function will just shift a bit further down. So meaning we are now moving away from that y-intercept, and look what's happening. We are no longer intercepting that function on top of the y-axis, and again we are no longer intercepting it when our x values are greater than 0. So by adding any value that is less than that, we are getting both parts of our solution correct. We will never intersect that function. So So let us say we add negative 6.3. Negative 6.3 is obviously lesser than that. So we'll move this function further down. It's going to go like that. Look, we are not intersecting it, right? So that means the correct solution is if ever, is if our k value is less than negative 16 divided by 3. Yeah, and this question is just 3 marks. Yeah, that's it.